We would now like to introduce you to our Zeus form knurling tools. Step by step, we will demonstrate the necessary settings and the required preparation for each tool type. The Zeus product program comprises of the tool series RD1, knurling tools with one knurling wheel, RD2, knurling tools with two knurling wheels, and RD3, knurling tools with three knurling wheels. With the Zeus series RD1, all knurling profiles can be manufactured. The tool holder is also suitable for marking purposes. The required knurling wheel is always the counterform of the profile desired on the workpiece. As a general rule, the workpiece itself should be prepared to achieve concentricity before knurling starts. The workpiece is therefore pre-turned, as we can see in the picture. The next step is the adjustment of the center height. The center height of the RD1 series is the top of the shank. The center height is integrated in the tool for CNC tool holders. Radial tool direction. When working in the radial tool direction, the tool is clamped at an angle of 90 degrees to the workpiece. Our recommended values for feed and speed rate can be found on our website. We can see the knurling profile RAA, RD1, axial tool direction. With the Zeus RD1 series, it is also possible to work in the axial tool direction. In order to achieve a good knurling profile, it is necessary to set a clearance angle. In order to set the clearance angle, the knurling tool is carefully brought into contact with the workpiece. Now the tool holder is clamped with a clearance angle of 2 degrees to the workpiece. In the next step, the tool is brought into contact with the workpiece again. Now the impression should be approximately 1/3 of the knurl width. We can now start the knurling process. Ensure a sufficient supply of coolant. We see in the picture the knurling profile RAA. The knurling tool series RD1 is also suitable for knurling to a shoulder. Series RD2. With the RD2 series, the profiles RAA and RGE can be manufactured. The tool and workpiece setting corresponds to the setting of the RD1 series. After the setting of the center height, the plunge knurling process can be started. With this tool, we have knurled the profile RGE 30 degrees. We have used two knurling wheels of the form BL and BR 30 degrees. Tools RD2, axial tool direction. When working in the axial tool direction, it is also necessary to set a clearance angle as demonstrated. With the RD2 series, it is also possible to knurl to a shoulder. We can work in both axial and radial tool direction. Zeus experienced precision at its best. Form knurling tools RD2, RD2, tangential tool direction. The tangentially working tool types are characterized by the minimal lateral pressure which is exerted on the workpiece. The knurling tools 161 and 162 are especially suitable for the processing of small workpiece diameters. With this tool type, the profiles RAA and RGE can be produced. The tool is clamped at an angle of 90 degrees to the workpiece. In the next step, we adjust the center height. In order to center the tool, we have to measure the workpiece diameter first. The distance between the two knurl holders is then set with the setting screw. The distance should correspond to the workpiece diameter less the pitch of the knurling wheel. After centering, The workpiece centre corresponds to the knurling wheel centre. The machine spindle can now be started. The setting screws are turned to the right until a clear profile is formed on the workpiece. Now we retract from the workpiece and tighten the locking screws and the locking nut. The knurling tool is now set for the required workpiece diameter. The knurling impression should now be checked again. Should the profile not be fully formed, the setting of the profile depth can be adjusted and the actual knurling is repeated, as demonstrated. The RD2 series can also be used in the axial tool direction. Setting is the same as for the radial tool direction. Are the RD3 series, the operation of which will be demonstrated in the following section. The RD3 series is characterized by its minimal wear on both workpiece and machine. The knurling forces are completely absorbed by the tool itself. The 3 knurling wheels ensure balanced knurling. With the RD3, the profiles RAA and RGE can be manufactured. Before the actual knurling process, we should ensure concentricity of the workpiece. With this knurling tool, we recommend that the workpiece is chamfered so that the knurling wheel's teeth can engage more easily with the workpiece. The next step is the tool centering. First, we disassemble the knurl units. The locking screws are loosened. The adjusting ring is turned to the right so that the jaws are wider than the workpiece diameter. Now we move over the workpiece and loosen the centering screws. The adjusting ring should now be turned to the left until all 3 knurling units enclose the workpiece and centre the tool head. The tool head is now centred and all 3 centering screws can be tightened. The centering ring is turned to the right. The tool can be retracted and the knurling wheels. In the following part, we will turn to the cut knurling applications with the Zeus cut knurling tools RF1, RF2 and RF3. The RF1 series is suitable for the manufacture of the profile RAA. When cut knurling, only an axial tool direction is possible. Tools RF1. The workpiece preparation is more extensive for this technique. After pre-turning the workpiece to ensure concentricity, it has to be chamfered. If the knurl is to start in the middle of the workpiece, a groove is required. As a next step, the centre height is adjusted. Centre height is integrated for all Zeus knurling tools suitable for CNC lathes. The tool can now be clamped at a 90-degree angle to the workpiece. Now follows the adjustment of the clearance angle. As can be seen, this requires the tool to be brought into contact with the workpiece. The knurling impression on the workpiece should now correspond to about 1/3 of the knurling wheel's width. A correction of the angle can be made by the use of the setting pins. The clearance angle should now be adjusted correctly. We now have to define the 0 position of the tool. We move about 1 mm in Z- and 1 mm in X direction. As a last step, the profile depth needs to be set correctly. The machine spindle is now started. As a general rule, the profile depth equals the tooth depth plus 1/10 of a millimetre plus minus 5/100. After achieving profile depth, a short dwell time of up to a second follows. In this way, we have obtained the knurling profile RAA. Zeus experienced precision at its best. Frequently, an error in knurl straightness is caused by the parallel position of the tool head. If the profile is not parallel, the head has to be tipped by means of the setting pins. With an upward spiral, the head has to be tipped to the right, with a downward spiral to the left.